My name is Mush'ab Nursantio. I'm the co-founder and CEO of BiteBack Biotechnology. We are biotechnology startup based in Singapore that developing a nutrient-dense, more sustainable alternatives to palm oil made of edible insects. So outside of BiteBack, I also co-founded another company called SentraFarm here in Jakarta, and also work in some non-profit in the same space in food technology, and also do multilateral advisory work as well. So here I would like to tell you a little bit more about edible insects and the benefits, its forgotten benefits for the society and environment first, and then we can uh, fit the puzzle together at the end to how this insect could be beneficial for our basic generation. So edible insects. Right now we are facing this problem here in the world that we are facing global. Yeah, we are heading the population growth heading towards 9 billion people by 2050, and at the same time we have this problem in the input to produce food that one third of the arable land are not productive anymore because of the industrial farming, the extensive use of chemicals, and 70% of the fresh water are used for agriculture. And we have this problem that the increasing demand for food and the problem with input to producing it. And right now, our most of if you look at the sea, most of our protein source are coming from the sea, which one third of this fish that we caught are using as input to feed animals on land. So not only that we eat fish directly, but also we caught a significant amount of them to feed animals, like for aquaculture feed, livestock, or poultry farm, for example. And this is not sustainable because the fish stock itself on the sea cannot sustain the demand for feed on land, right? And this is the amount of the fish that we caught, like 65 million tons for human consumption and 30 million of it goes to animal feed. So it's not efficient system. So this is where the insect coming really really fit in as an alternative, because they are rich in protein, all the micronutrients that instead of caught fish on the sea to feed fish on land, we can grow this type of insect to replace it. And for other protein consumption, that 70% of the previously forested areas are now occupied by ranch cattle, and as well as the space to grow the feedstock. And if you look at the insect as well as human consumption directly to replace meat, we can have options that are more sustainable. They are the most efficient animal protein, with conversion rate around 2 to 1 compared to beef need 25 kilograms of feed to produce 1 kilogram of food. And this is compared to other source of animal proteins. We see these insects are more make sense to more efficient to produce. And the water consumption, if we see beef, for example, we need 22,000 liters of water to produce 1 kilogram of protein. Meanwhile, edible insect only require 1 liter of water to produce 1 kilogram amount of protein. And that's so by consuming it directly or indirectly to feed the animals we cultivate, we see the impact how we reduce our dependence on exploitation on land and on the sea. And if you look back, if you look at from we are from here in Indonesia, in Southeast Asia, we have the same problem as well with the rainforest, which but instead of protein, we use the forested area are cleared to make room for palm plantation. Palm oil is the most used vegetable oil in the planet, and it can be found in almost half all packaged items in supermarkets, right? So, if we so some people might campaigning against palm, but if we look at the alternative out there, palm oil remains the most efficient compared to other sources of vegetable oil. It has better yield, require less fertilizer, pesticide, and energy input, you name it. So if we move towards other vegetable oil, it will only create the same problem or even worse in other parts of the world. So that's why the main reason, basically the background behind why I founded this company. So we look at at BiteBack we look into other source of fats and oils that is coming from what's called the Zopobus boreal alpha. So they are so efficient that they reproduce so rapidly that outdo palm oil in production by almost 40 times. So in 1 hectare of land, we can produce 150 tons of oil per year compared to palm oil only 4 tons per year. This makes sense because one single adult beetle can lay 500 eggs every 2 weeks. Meanwhile, for palm, you need to wait 5 to 7 years from for the first harvest since the plant is planted. And yeah, so it also doesn't require a lot of input like pesticide, other stuff. So it can be fed using biomass from agriculture waste stream, you name it, rice husks, wheat husks, sugarcane bagasse. So massive biomass that available in this region. And at Bayer, we are developing the technology to refine these extracted fats into highly functional ingredients like cooking oil, for example, butter alternative, fatty alcohol for cosmetics, and biofuel for energy. This is the sample of shampoo made of insect-based oil. This is the biofuel. And yeah, so if you look at we've seen the nutrients, micronutrients, the macro and micronutrients in the insect. Like for example, it's rich in protein, higher uh, iron than spinach, higher calcium than milk, etc., etc. But also, if you look at the fatty acid properties, which is one of the essential biomaterials and macronutrients, insect has wide range variety of fatty acids, which that most of them available in palm. You can also find it in insect oil, palmitic acid, linoleic acids, etc., etc. So that's what makes this specific species of insect are so versatile. And yeah, so when we look at this, the abundance of these resources that now still underutilized or forgotten the benefits, if you look at the total amount of insect there is in the earth, there is 2 million 200 or 2 million. I'm almost forgot, but around that, I think 200 million of insects for each individual human on the planet. So basically, we are not living on the planet of man, but we are living on the planet of insects because they are way more. There are more than insects than us, and if we look at space application and space application, of course, with this highly what's called exponential growth in their reproduction cycle, and the amount of space that they used to grow to cultivate them. I think it's like the perfect micro lifestyle. That the first thing that we need to bring if we are like making a colony in other planets, or with this highly nutritious derived products, we can process them to as meals for our astronauts for the space journey. And yeah, if you look at the basically the biorefinery products from our operation in BiteBack, outside of the fats and oils products, we can also have byproducts that are highly valuable, like protein, derived from the fresh cake waste. When we extract the fats, it has 70% on protein per 100 gram dry matter. So it's very valuable for direct human consumption or to feed the animal. The insect frass, uh, it it's also rich in nutrients that needed by plants. Insect fresh is the excrement from the insect farm, and the chitin. So the ant beetles that no longer productive to lay eggs, we can extract the exoskeleton to extract the chitin and produce chitosan for to be by plastic or for food preservation. Yeah, maybe we can combine the technology from Dr. Ronnie to process it further for various applications, right? And yeah, to grow them is really easy. Does it could be done vertically, scaled vertically, and done indoors, so it's perfectly fit for growing them in interterrestrial environment. And these some of the products that, so basically BiteBack is B2B company. We produce ingredients for manufacturers, but also we sometimes we do like uh, consumer facing products as investment in consumer interest to educate consumers, etc. So these some of the products that we have developed, like for example insect cookies with packed with insect flour and insect protein, baked mixed with the insect butter, protein chips, uh, yeah, basically insect flour with rich in proteins and deep fried with insect cooking oil, insect pulse, and yeah, other application outside of biomaterials and nutrition. It's this insect could be used to there are some types of insect to to be used as tools or to transform other biomass, like for example the waste that we produce in space, like the feces from the astronaut, it could be fed to other insects, for example the black soldier flies or the plastic itself. Now there is space just the called is waxworm, the larva stage of same darking beetle, but from different family. It's they can digest plastic, and also the insect that we are using could digest like styrofoam like material. So this is like not only they could produce wide range of biomaterials and nutrients, they could also take input from our non-valuable byproduct or waste. Maybe that's it. Thank you very much.